And I'm going to talk only a little bit about maybe one or two patterns that are from the famous Gang of Four book, but I'm going to talk more about some of the patterns that have been around for much longer, but either they have been forgotten or we just are not aware of or we don't use it in traditional languages like Java. And also, with the dynamic languages emerging, I think there's a great benefit to relearn some of those patterns, and we can take benefit of some of those. That's what I'm going to do here today, is to talk about some of the ways we can apply some of these patterns. So let's get started with the very first one, which is probably one of the most famous patterns or most popular patterns, which is the abstract factory pattern. The abstract factory pattern allows us to separate the concern of creating objects. So if we are creating objects and using new in various places, if we decide that we don't want to create that particular object but want to create some other object, we may have to modify the
kilometers daily, and 22 plus 22, 44 kilometers. That means around 3.5 hours in bus. So that would mean a lot of void time for me. And some meetings wherein I am just a silent participant. So that's again a lot of void time for me, right? So let me just give you a glimpse of what I do in my void time. It no longer is void. It used to be void for me. From the last 1.5 years, it's no longer void. It's much, much more productive. So my activities on a typical day, this mine is mine in the sense like it's mine and some of my colleagues and some of my friends, so you can relate to that. I check my mails on Gmail. I have this personal mail, check. So how do I check? I use the small device. Okay, I use the small device and check my Gmails. I have an application which checks my Gmail. And then I look at how my stocks are doing on Money Control. Money Control has this latest application which you can download onto the mobile, and I use that to check my stocks. Not a very happy thing, of course, if you have invested stocks last year, to look at the rates right now, it's not very encouraging, but still I do it. And then I watch some promotional videos on YouTube. So there are a lot of small videos which is for viral marketing. So those kind of videos are nice to see, regardless of whether you like the product or not. So these are some of the videos that I watch over YouTube. This is yet another application. Okay. Then what else do I do? Some sites I go and browse using Opera Mini. I have Opera on my PC, so I'm comfortable using Opera browser. So I browse few sites using Opera Mini. Then I fiddle with the city maps. I'm a Bangalorean, so I don't need a map to go around the city. But of course, I just switch on my application and see if the application shows me the right routes and shows me the right landmarks, etc. And then I check my Twitter. Twitter is a microblog, in case you didn't know. And then my blogs and the weather. You never know what happens to the Bangalore weather. You don't know when the rain starts coming. So you check if it is going to rain in the evening, right? And all those using a small application known as widgets rather. And then pay my mobile bill using mcheck, and of course play games. I'm not a very game kind of guy. I'm past my age, I think, for that, but still I play some games there. So if you see all this, these activities are filling my void time and using it very productively. Now, even though Java has entered its teen age, there is a small guy in Java who is a child prodigy saying, I am here, I am the future, okay? And that is called mobile Java, Java micro edition. And all these activities I do are by applications which are powered by mobile Java, that is Java micro edition. So more or less you're getting a power of what Java can do on your mobiles. Most of you know what Java can do on enterprise. I'm sure most of you know what it can do on mobiles, but these are the kind of activities you can do on your handheld device. Okay. Tomorrow, let me tell what I would like to do. I would like to watch TV on my mobile. Okay. I would like to using direct video broadcasting handheld. Now there are mobile phones capable of receiving direct video hand broadcasting. And then transact with multiple servers using single sign-on. That means I don't have to log into Yahoo once and Twitter once and Gmail once. I have single sign-on. Okay. Pay supermarket bills. I go to supermarket shop and just show my mobile and my transaction is complete. Okay. Share my location. Somebody asks my location here, and what I can do is to share my landmark with you using my mobile. Okay. All these again will be powered by mobile Java. Okay, so you know the kind of things that mobile Java is able to do, right? Let me take just three important applications on mobile Java, which will tell you as to what exactly the power of mobile Java is. Okay, widgets. This is a screenshot. This is a screenshot directly from my mobile. So if you see there, you have a big blue box. Inside that you have small boxes, right? So the small boxes, one is showing the weather of Bangalore. Then you have Wikipedia. Then you have Twitter. Then you have Times of India, Google, etc. These are called widgets. Okay, these are small widgets. So in case I'm to browse Times of India daily, if I go to Times of India, it will show me the news. If I browse using a browser, then it will show me news which I have read before. So that's not productive for me, and the browsing experience I'm sure will not be that great. At the same time, if I use these widgets, it's personalized for me. It's localized for me, and it's always there with me, and it's always there everywhere. So these 4 points, these 4 characteristics of mobile, when you merge it with the social web, you give birth to mobile 2.0. So actually what Widgets is doing is it's mobilizing web 2.0 for you, giving these properties, right? So this particular widgets is nothing but set of widgets, something which has a set of widgets. So this particular application, let's see, it's basically an aggregator for RSS feeds, okay? And then brings the spirit of Web 2.0 onto mobile phones. When I tell you these activities are something which I used to do it on a PC, right? And then it broadens the reach of mobile phones. Something which I used to do, which I go to the browser and used to do on a PC, I now do it on my mobile phone, right? So, and one more thing is it minimizes the consumption. Since the bandwidth is very less, it minimizes the consumption. And then, as I told you, true to the characteristic of a mobile, it's personal, it's local, always on, always present. Okay? The biggest thing is it's mobile Java. The whole platform, that platform itself runs on mobile Java. So now you know the capability of mobile Java. Right? Similarly, a lesser known application, that's location-based service, then we have mobile Gmaps. This can, show you the locations, and I can bookmark my location, switch map types, and much more. What it does is to get the GPS information and get the information of map from, say, Yahoo Maps. Now Google Maps is no longer supported. Yahoo Maps or some other maps, and collaborate it and show you the map. Okay. And what it can do is an interesting application is at periodic intervals, it can post your location to your website. And if you make it public, if they give you a particular link, and if you make it public, your friends or anybody can monitor as to where you are. Not monitor, can see where you are. Okay, that's very interesting. And again, that's also mobile Java. And then we have the latest entrant is Skype. Skype on S60 phones is on Java. So it's still a beta release. And then we have MIG33. And then we have chat and exchange instant messages, of course. Then make voice calls. And then send cheap international SMS. All these activities. So you can get connected to a network. So again, this is also Java. So you saw the kind of activities that you can do. You have entertainment, you have media consumption, you can network, you can communicate, everything that you want, really, right? So let's now go to the next slide and see. for statistics sake, 1.3 billion internet users are available globally, whereas there are 3.6 billion mobile phone users, mobile phone subscribers. So that is the reach of mobile phones. So it's going to be mobile phones which will drive the growth of internet. It's not just me telling, it's everyone. And you can experience it, right? And then we have this multimedia personal computer, which used to be called as phone, and we sometimes call it a smartphone. Okay? For every one PC or one laptop or one Macintosh sold, you have 4 mobile phones that is getting sold. So that is the power of the mobile phones. If PCs used to unleash innovation, this mobile phones will unleash innovation in the future. Not in the future, it has already started. This mobile phones will be the future. Okay? And then, what all can you do with this kind of multimedia computer, handheld multimedia computer, which used to be called as mobile phone? You can snap print quality pictures. You can listen to music. You can browse email. You can watch TV. All this on the move, right? So you have all this. If you see on the right side, you have a TV, you have a PDA, you have a camera, you have iPod. All this converges together into one device. When all this converges together into one device, you have Web 2.0 for you coming on your device. It mobilizes you with Web 2.0. It gives you this converged device is a tool for you to access Web 2.0. So you can browse rich internet content, you can play music, you can do whatnot. You can share your photos, you can you get all sorts of ability. So if you see all the right side converge together to form one device, and you have all the services on your left side together, they form a converged service. Okay? Ladies and gentlemen, please welcome the 4th screen. Mobile phones will drive the consumption of internet and media. Internet and data and media will be driven, the consumption will be driven by mobile phones. The first screen was the cinema, the second screen was our TV, the third screen was our PC, and the 4th screen is going to be mobile phone. This mobile phone, you will start using the mobile phone for every aspect. It will start consuming all the data in the internet. So, to just remind you of what our MD D. Shivkumar told a day before yesterday, he told that once 3G is introduced in India, you cannot imagine the amount of internet usage that will happen over mobile phones. So, this is going to be the 4th screen, or already it is the 4th screen. Okay? So, if you want to just look at this strong growth of converged services, converged devices, year on year from 2007 to 2011, we will have a growth rate of converged devices at the rate of 40%. At the same time, non-converged devices will grow only at 3% or less. So now you know that converged devices will be the future. You will have more and more converged devices. Okay. Having said all this, it's a mobile Java presentation. Why are you talking about all this? So you must be wondering, as the capability of the devices have been improving rapidly, has mobile Java kept pace with this kind of improvement? Yes, it has kept pace. But let's take a look at the evolution of mobile Java. Okay. So as the capacity increases, let's see. Initially, what started off was in somewhere in 1999. You had the basic profile defined, that is mobile information device profile, which can run application, which controls the life cycle of application. Application that runs on Java applications that run on phones is called midlets. Okay, anyway, which can run midlets on a device which has limited capability. That is what is CLDC. Okay, device configuration for a device which has limited capability. Okay, then came another MIDP 2.0. MIDP 2.0 had facility for more communication, more secure communication, some UI changes and things like that. It brought down some clarification. And apart from MIDP and CLDC, there were a series of extensions. Okay, there are optional extensions. So what used to happen is, in Java, you write, the slogan of Java is, write once, run anywhere. But what used to happen is, write once, run in one place. Because something which runs on Nokia device never used to run on Motorola device. Something which runs on Motorola device never used to run on Sony device, Java applications. Because there was total fragmentation. Each device manufacturer had his own, his own implementation of the Java extensions. When you had such implementation, there was total fragmentation. That gave birth to a new specification known as mobile service architecture. Okay. Now you have mobile service architecture which reduces fragmentation, which takes the capability of the device, which takes all the capability of the device, and you have this new architecture. This is again for limited device. Then what we have is mobile service architecture 2.0 for devices with better capability. Okay, L is removed there. L stands for limited. Now we have CDC. Okay. Now, apart from that, there is a profile MIDP 3.0 which is defined, which is almost like an operating system. You can have inter-application communication. Okay. Then there is something called shared library concept, so that your footprint of the applications will be very small. You have a series of applications using a common code base, and so common library which is called liblets. Okay. But MIDP 3.0 would be I feel it would be the last specification of MIDP, because the rate at which the converged devices are growing, Java wouldn't be able to keep pace. If it just restricts to open standard, it will have to go open source. So the growth of Java for the next 5 to 10 years depends on how fast open source is adapted. Okay, so this is my opinion on MIDP 3.0. Don't come back to me if MIDP 4.0 comes tomorrow. Now let's look at the capabilities of Java. Java for graphics, audio playback. I don't have to talk about all this. Anything related to audio, anything related to video, image capturing, etc. Then anything related to 3D graphics and scalar vector graphics. So then you have the mobile broadcast. Mobile broadcast is a new kid in the block. What you can do is there are handsets which can receive from the direct video broadcasting. Okay, so there are APIs to receive those and start displaying the video for you. Okay, then we have mobile Java for communication, SMS, MMS. I don't want to speak about it. Session initiation protocol, you will know. Bluetooth, you know. There's one thing called contactless communication. When it comes to contactless communication, I have to tell you something. In 2 years back, Government of India introduced this National Rural Employment Scheme. Okay, and this was launched in a few districts of India, and Warangal in Andhra Pradesh was one of the districts. Now, there was a remote locations in Warangal where the wages had to be distributed every Saturday. They were remote locations very far from banks. So how do you distribute it? They were promised that you will get wages. So how do you distribute it? Now, what they did was to have smart cards, and smart cards were given to each laborer. Okay, and a person from the bank, okay, comes with a handheld which is called as mobile. Okay, he comes with a mobile phone and he verifies the credentials of each person. Okay, and disperses the money. Or if that fellow wants to give, put money into the bank, he used to do it. So just one person with a mobile phone coming there and doing the transaction. Okay, this is called branchless banking. Okay, this was enabled by a technology called near field communication. This is going to be the hottest thing in applications, mobile applications. The near field communication, in the next 3 years, 25% of the phones will have near field communication capability. Okay, when that comes into picture, Your mobile phone can be used as a debit card. It can be used as a swipe card in your, as you get into your office or somewhere, and then it can be used for payment, e-ticketing, whatnot. So we have contactless communication, which has APIs for communicating for NFC, that is near field communication, or as well as RFID. So probably Java is ahead of time sometimes. Then we have for personal information file access, personal information management, that is accessing the information from your contacts, etc. And then you have location, and then you have web services, security and trust services, payment and mobile internationalization services. Okay, this is the MSC, that is Java ME platform for converged devices, which we talked about. Okay, it reduces API fragmentation. Okay, then let's look at the role of open source in mobile Java. When you're open source, you're not limiting innovation. All the innovation, you're not limiting any innovation, you are breaking the barriers for innovation. Okay, platforms will be on fast track to convergence. Okay, and then let's look at open source in mobile Java. There is one project called PhoneMe project, okay, which is open source. Then we have ERCP built on RCP. This is an Eclipse-based project. This is again open source. Okay, then we have, to give you one example of how open source helped. Okay, there is in Java specification, there is something known as limited configuration device UI. And that particular UI used to draw UIs, and that was not as flexible as the capabilities that you get in desktop. So what we had is Java ESWT, okay, so Nokia and IBM combined together and formed ESWT, that is Embedded Standard Widget Toolkit. So this was familiar. Okay, you could create something which you create using on desktop, and then it's based on open Eclipse platform. So this is one example of how innovation can be fostered if we bring in open source. Just to tell you that the kind of reach that Java has, okay? Java is 83% of the total applications, 83% of the applications run on Java, right? To give you some more statistics, 814 million mobile Java devices in the market, and you have 220 operators worldwide have deployed Java services. This usually happens in North America. And you have 1,200 mobile handsets by 35 plus vendors in the market, 55,000 mobile Java applications in the market, and 1 million mobile Java developer toolkits have been downloaded already. And then we have this is something very interesting for all of us, 340 million euros annual Nokia-based revenue for developers scattered around. I know this is actually utilizing the long tail. So how do you start? You must be thinking, how do you start developing converged devices on Java? We have, best thing to do is to join a good mobile forum, okay? And this comes with Forum Nokia. We have Forum Nokia, which is a fastest growing and the largest mobile development forum, okay? You can download top quality SDKs, and you can network with communities using blogs, wikis, and all those. And then we have support for you have a very good application, you have a very good idea, you don't know how to market it. Forum Nokia identifies the right channel for you. Okay, so these are the kind of applications that you can develop. So just to summarize, you know now the capability of mobile Java, and you know how it will accelerate convergence. Sometimes it is much, much ahead of time, ahead of the device's capability. So having said this, thank you all for listening, and please go to Forum Nokia and register yourself so that you get experience on how to develop converged services. Thank you very much.
the closure that's given to me and say delegate equals the resource that I'm dealing with, and I can get rid of the resource object from there, and notice how the code is working again. So you can pretty much use these patterns and simplify the code quite extensively. Like I said again, if you're doing these in other dynamic languages, you can still do this in other languages. Syntax is going to be a little different, but the concept is pretty much exactly the same as you saw here. Now, of course, you could look at this and say, can this be any simpler? Well, the answer is eventually yes again, and you can remove that piece of code, and you can simply say resource.with and send the closure to it. This is a bit of more details on the Groovy syntax, but like I said, almost every time I ask, can this be simpler, it seems to be falling in size, right? It keeps shrinking in size, and it still seems to be continuing to work. So you can refactor the code pretty succinctly in the case of these languages and still achieve the behavior. So that is an example of how you can use the so-called execute around method pattern. I've also used this pattern very effectively in C# using the anonymous delegates. The anonymous delegates in C# 2.0 give you this capability, so the code is a little bit more elegant in C# 2.0 than it would look in Java. Of course, using closures and lambda expressions, it looks even more elegant in Groovy and other dynamic languages, as you can see here. So that is basically the execute around method pattern. Cascade pattern is yet another pattern. This can be very useful for creating fluent interfaces. I spoke about this quite extensively yesterday in my DSL talk, and this gives you an ability to cascade methods. So this gives you a context and a fluency. You can see this quite a bit in several APIs. For example, this is used in JMock, for example, for mocking objects. This is used in Juice. When you inject dependencies into objects, you can say bind, and then you can bind it and then cascade it with the call to what kind of class you want to bind it to, and cascade it to another scope that you want to bind to, and so on. So you can see this quite effectively in a number of APIs and libraries. So how do you deal with the contexting? So if you notice over here, I got the mailer class, and notice the mailer class has a to method, a from method, a subject method, a send method, and so on. And I can simply concatenate these. I don't have to say mailer.send, mailer.to, mailer.from. I don't have to repeatedly use this. I can establish context and go on. This is also used in the JSON library. You would say new JSON library, and then you simply say accumulate and keep accumulating data to it. So if you notice in this particular case, we're breaking the convention a little bit, right? The traditional Java bean convention says, give me the getters and setters better return a void. Whereas now what you're doing is you're writing methods that return themselves, right? They return this. As a result, you can cascade them further. So that can be pretty useful to create some of these cascading. Once again, obviously, you can see the pattern emerging right here, right? This is going to be much simpler in Groovy and dynamic languages than you see here, and that is exactly the call that you see. Actually, this can be even simplified. You don't need the parentheses you see up there also. So you can write this in Groovy. I'm not going to show you this because we're not going to learn anything more than what we learned already, applying closures one more time. So that is, again, a different thought process, right? To have these objects chain themselves so that you can just cascade and call these. So I talked about a number of these traditional patterns. Now I'm going to talk about more patterns that are somewhat specific to these dynamic languages and frameworks built on it. But any questions or comments before I talk further? Maybe a couple of minutes of question can be entertained. I think. So edit text does almost everything that TextMate does, but it runs on Windows. So you can get almost the same kind of love on Windows by using edit text. And the third editor you saw me use was IntelliJ IDEA. That's one of the most fantastic editors ever invented for Java programming. So those are the three editors I was using. So this is a very interesting pattern. Now think about this for a minute. Yes, please.
I had a question.
Is that God? There you are, okay.
I had a question. One of the problems when we use anonymous classes, especially in listeners, is they very frequently lead to memory leaks. So does a similar problem exist when you're using closures?
No, they don't. Because the garbage collection, this basically translates into, it eventually translates into anonymous inner class behind the scene. A lot of times memory leaks happen because you are holding a reference to things elsewhere, right?
Because a similar problem exists in a lot of JavaScript code where you are passing functions along here and there.
Right. So yeah, you want to make sure those things don't creep in, but by default implementation, the answer is no. If there is, that's a bug that needs to be immediately fixed, and that's not our problem. It's a language implementer's problem, the framework implementer's problems, and the JVM implementer's problems. But yeah. So let's think about this for a minute. If you are writing code over and over and over, right, that is a crime. You don't want to do that, right? That's duplication of effort more than duplication of code. And that's what the DRY principle talks about, right? In pragmatic programmers, the DRY principle says there's got to be a single authoritative representation of knowledge. So if you are making a change here and then making a similar change in 7 other places, instead do a code generation. So rather than you writing code in 7 places, I would rather use a tool to generate the code. But having said that, I think that code generation is so 20th century, right? I don't want to do code gen anymore. What I want to do is a code synthesis. The difference is, in code gen, you spit out code, and then it just sits there and you compile it. In the code synthesis, there is no code you spit out on the disk. The code kind of comes to life dynamically. This is something that is used extremely effectively in, for example, Ruby on Rails, and it's also used in Grails in Gorm also. Think about this for a minute. I create an object, and this object has no methods at all. But assume this object is as part of the database, right? So this object in memory is actually a model which is in the database. Now I go to this object and say, hey, what's your first name, right? Now I'm calling this method called, what's your first name, right? Now the code can be written in a way that it says, well, I don't know what this method called what's your first name is, but I'm going to use a certain convention or logic, right? So I'm going to say what's your is something I'm going to spit out, right? Okay, that's a query, basically. What's after the what's your is the first name. So I'm going to say, I'm going to go to the database and see if there is a first name field in the database. Then I'm going to simply fetch that and return to you. So my interpretation of what's the first name is to go get that. Well, what's the big deal about this? The big deal about this is, if I'm adding the first name, if I have the last name, if I also have the phone number, then I don't sit there and write these 3 methods. So what's the big deal about it? The big deal is, tomorrow if I go add a fax number for this person, I don't have to add any code at all, because I can simply go to that and say, call the method, what's your fax number? And the code wakes up and says, hang on a second, oh yeah, fax number is a field in the database, so I'm going to get that for you, right? You get the idea of the behavior, right? It's extremely dynamic. So rather than you sitting there and writing more code, you can simply use this code, and that's pretty effective. But there's one problem though, right? The problem is, every time you call this method that doesn't exist, you're going to pay a toll, because it's got to go find out what this is and create this method, provide the implementation, right? Respond to you, and then it pays the price next time. This is where this beautiful pattern called Intercept Cache and Invoke pattern comes in. I'm going to show you an example of how you could do this. So let's call this class called person, right? So person has a method called work. And what this is going to do simply is to say print working, right? So notice I'm going to say Joe equals new person, and I'm going to say Joe.work, and it basically says working, right? Again, a simple example. But Joe is a very boring person. All that he knows to do is work, right? You go to Joe and say play tennis, right? And then you say Joe.play tennis. You can also say Joe.play violin. And guess what? He cannot do any of those, right? Because he's a boring person, he can only work. And you got a method missing here, right? So you say, okay, how can I make this Joe really dynamic, right? He goes out to the crowd and he says, you guys are playing tennis, I want to play tennis too, right? That's where the method missing comes in, right? So you want to be able to dynamically generate this. So what am I going to do? Of course, Joe plays tennis, plays violin, but Joe is still a good guy. He doesn't play politics, right? So if you say play politics, he says, no, I'm a disciplined person, I'm a decent person, I don't play politics, right? So there are certain things he can play, but other things he cannot play. How do you do this? So what I'm going to do is have a list of things. This could be very dynamic, if you will, but I'm going to say plays equals, I'm going to say tennis, and I'm going to also put violin, right? So those are the 2 things. So if you call play politics, I want him to reject it. Then I'm going to say a method called method missing, which takes a name and an argument. We'll take baby steps to implement it, right? So I'm going to say print you called, and then I'm going to simply say name. I call this method missing as the mother of all methods. It says if you don't find the method, come to mama, right? So it is a method that is extremely dynamic. So if you don't have a method, once again, it gives a last chance and says, do you want to handle this? Do you want to execute this? So if I execute this method right here, notice it says you call play tennis, you call play tennis, you call play violin, and it called that method. What was rejected a few minutes ago, it's calling it here, right? Now what I can do in this method is, I could do some actions like this. I could do something like, plays.find, right? And then I have a name of a method that I'm going to find. So this is the, activity, right? So I could say activity. And I could ask him, do you have this particular activity, right? Do you support this particular activity, right? So I could say something like this. I could say return, activity equals, and I could say something like, what is this? Name.split, and I could say split on play and get me the first element, right? We'll take baby steps. So I'm going to say print that particular value. So let's say over here, def is valid, and then equals, and then I'm going to say is valid, right? So if you execute this code, let's see what it does. Notice it says tennis, tennis, and violin, right? Just like that, we'll also go call joe.playPolitics, and let's see what happens in this case, right? And notice in this case, it gave a null. Making sense? Right? So now we have a way to find out if this is a valid activity that Joe participates in, and obviously politics is not one of the things, but tennis and violin is. So now that I know it is valid, what do I do, right? So I'm going to say if is valid, then I could implement my method, whatever I want to do. So I'm going to say, Joe is playing, and then I could say simply here, something like, I can just grab this, right, from here, from this one here. Okay, so let's just grab this part here, and then pull that in down, and I'm going to simply put that here, right? So that's good enough for me. That's my implementation, let's say, right? So basically, notice it says Joe is playing tennis, Joe is playing tennis, Joe is playing violin. There's still one problem, right? So just to quickly, note, this line that you see right here is the place where you'll put the real implementation, right? This may go look in the database or, make other calls. That's your business domain. Whatever you do, that's your concern. There is still one problem in this code. What's the problem? The problem is, if you notice, if I go up here, I'm going to say print line, I'm going to say, hey, found a missing method, and I'm going to say name over here. So if I execute this, notice it says, hey, found a missing method each time you call, right? That's the toll you're paying. Each time you call this method, it's going to go through this looping, and certainly that's redundant, right? You don't want to be doing this. So here's what we're going to do. This object is going to start very small. It has no methods. You call a method that is unknown, but it's a valid method. Now, the first time you call it, it'll respond to you, but it'll grow a little bit now, right? Now it's got one method, it's accumulated. So next time you call it, you're calling a method that exists already, but that method that exists was synthesized rather than being written ahead of time. How do we do that? So here's what I'm going to do. I'm going to go back to this class and say, okay, before you respond, I want you to first create an implementation for that particular method. So the implementation is going to be var args, because I want to store this away. Multiple arguments could be given to me, and that's basically a closure as you recognize it. And in this case, I'm going to simply print that particular response over here. That's all I'm doing, right? So right there is the var args. I'm saying printing Joe is playing. Actually, this should be not even Joe, right? Because we don't know who it is. So I'm going to simply say is playing. That's good. Now, notice in this case, I've put it into an implementation. Let's take baby steps. And I'm simply going to call that implementation from here and send in the arguments given to me, right? So if I execute it, we haven't solved the problem yet. I'm simply slowly refactoring towards solving the problem. So notice he says, hey, he found a missing method. Hey, found a missing method. He's doing this for each of the calls again. But now what I'm going to do, I'm going to say, hey, why don't you cache this method so the next time you're called, you don't have to go through this process, right? So notice what I'm going to do before I call this method. In this case, of course, I would have said a return in this case. So what do I do in here? I'm going to say, this is what person, right? So person.meta class, right? And then I'm going to say for the meta class, I'm going to say name, and we know this already how to do this, right? Because it's a dynamic name, right? Equals IMPL, the implementation we just cached away. So now I injected this method into this class dynamically at runtime, right? I said, look, you don't have it, That seems like a good method to have. Why don't I help you? Here's a method for you, go along, right? So the next time you get called, you go into that injected method rather than the interception that you see here. Of course, for this to work, you're injecting an existing method. So I'm going to say, so that is a bit of a kludge right now, so ignore that, but that's needed for injecting into existing methods. But notice what happened this time. You call play tennis the first time, it intercepted, it says, hey, found a missing method, gave you the play tennis method, but the object now acquired a new method called play tennis. You call play tennis one more time, it says, cool, I know this already. I don't have to go to the method missing, right? Because you have injected this behavior into me. This is an acquired skill, right? You come to me and say, hey, do you know to program this language? I say, oh, wait a minute. And I go take a crash course tonight, right? And then I come to you and say, yes, and here's the code, I've done it. Next time you come to me, I don't have to take a crash course. I've already acquired that knowledge, right? So I know this already. But of course, if I call play violin, since that's a new method, I'm intercepting it and I'm providing it. Of course, play politics is not going to do it. So every time you call play politics, it's going to check and fail, and then you can throw exceptions and so on. So this is a very interesting, a pattern where you dynamically synthesize methods, but at the same time, you don't take a performance hit by caching this method for future calls. And so you get the best of both worlds. Your code is extremely dynamic, but at the same time, you haven't lost any performance in this particular activity. So this is something that's being used extremely effectively in frameworks like Rails and Grails, so you kind of know what's happening. So when you see something that is pretty peculiar, just don't say, wow, that's cool. Start digging a little bit. It's like, well, how do you do this? Why do you do this, right? And then once you realize it, you realize you could use it in your own applications and take advantage of those, and that's what these guys are doing in these particular frameworks. Any questions or comments so far? Rails and Grails. Rails is a Ruby-based framework for web applications. Grails is a Groovy and Java-based framework. I'll type those two here. So, so those are the two fairly popular frameworks that do quite a bit of right. So I can go home. Right? So I can go home. It is extremely dynamic. You can come and enhance your data model, but I don't have to be sitting there and changing the code repeatedly. So it's extremely dynamic.
So once it is deployed application, you don't really change anything in the data model.
That's your life, but that's not my life. That's what I'm saying, right? Everybody in the world doesn't have to take a malaria medicine, but there are people who need it, right? So if your application has no need for it, that's great. But a lot of times our data model evolves even during development. We keep doing the play up, it's like, oh, wait, what do you want here? Oh, that's not what you want here. And you sit there and, you introduce a field, ask yourself, if I add a field to a database, next time you go to work, you say, if I add this field to the database, how many places am I changing the code, right? If you want to keep changing that code and spend the time, there are ways that you can eliminate it. That's what this gives you the ability to do. So you don't have to be sitting there and modifying the code when the code can be synthesized using certain conventions. That is not to say that we will never write code anymore, right? So there are areas where this is the dynamic behavior. Why do you have Java beans? The reason why you have Java beans is because my classes can have properties, but I don't want to be writing code to access every property repeatedly. I can loop through and process them. Take that to the next level. Well, if that is the case, how do I go fetch these data? How do I synthesize these methods dynamically, right? And that's where it gives you the greater power. So when I write a web application, I see that I'm doing exactly the same thing over and over and over, but the data properties are very different. But what I do with them is exactly the same. And I sit there and I get very angry, very frustrated, right? Because the code is exactly looking the same, variable names are different, method names are different, right? And I'm sitting there and writing this, that's a total waste of my time, right? My blood boils when I look at it. Why? Because I would much rather be doing other things than copying this method over and modifying all these variable names. Well, you can completely get rid of all of that code, right? So I would start with a code like this. I first make sure it works, right? I don't want to be sitting there inventing, solutions for problems that don't exist. But once I do it 2 times, I say, wait a minute, these two guys look awfully similar. how can I get rid of it? Then I start refactoring it, right? And then it just shrinks down and it looks like a small tablet, right? But it's extremely potent, right? And it says, look, you call me and I'll take care of these problems for you. And like, okay, now I have a reusable component. Now the third time around I have to do something, the work is already done. So what I want you to do is, when you go back, be extremely critical, right? If you do the same thing third time over, leave work. I will not code anymore today until I think about solving this problem. Otherwise, you got this huge bloated application. When somebody comes to me and says they have a 3 million lines of code, I say, I'm sorry, with all respect, I don't have any respect for that, right? Because that just simply means that you got a lot of duplicated code probably, right? So capability of the application is not in the size. It's in how you're really implementing the features that you really need to be implementing, and you can improve on these quite effectively doing that. All right, so I want to just mention a couple of things. I got about 15 more seconds. You can do something else as well with this. This is the next example I want to just kind of point to is delegation. Those of us who are familiar with object-oriented programming for a while know.
I have one question.
Oh, please, yes.
Can we inject the attributes the way we do?
Can I inject attributes?
Yeah.
Like properties of classes?
Yeah.
Yes, absolutely. You can inject just about anything you want to inject.
Okay, so what would be the behavior if I serialize that class?
The serialization you will have to implement yourself as well. But remember that serialization doesn't happen automatically all the time, right? It's usually a pain in the neck because versioning of serialization is a problem you have to be concerned with. So similarly, you have to deal with it. Absolutely. But a lot of times, again, serialization is a very narrow problem, right? A lot of times, I don't serialize my data at all. It resides in a database somewhere, right? So yeah, serialization is a narrow problem, but you have to handle it. But that's not a major concern most of the time because I very rarely serialize my object to the disk and leave it there.
Okay, basically like initially the class will be smaller and after deploying and when it is running, it grows. That's
Right.
the concept.
Well, that's not the intent, right? The intent is not to grow it. The intent is to only provide the adequate behavior, the code behavior, and whatever can be synthesized, you synthesize. The goal is not to say it's small and now it grows. That's the effect, not the goal. The goal is to say, don't sit there and write things redundantly, it can be generated. That's where the metaprogramming comes in. So the next thing I want to kind of point, yes, please.
So then the JVM, thank you. Does the JVM see any difference between this dynamically added method and the typed method?
That's a good question. That depends on the language that you're using, right?
Groovy will ultimately compile to just a bytecode, right?
True, that's true, but that doesn't say anything, right? Because there's a meta class layer involved. Fundamentally, again, don't take what I'm saying as the gospel. I'm talking about what's as if now may not be the same in a couple of months to a year, right? So just keep that in mind. So remember that Java classes, once you create, are pretty much static, right? You cannot change the classes once it's compiled and created. So what Groovy does pretty smartly is it has a level of indirection, which is the meta class. So what happens is he says, well, I'll leave you alone, but I'm going to tag along a meta class, kind of like a proxy, but not a proxy, right? So when you call a method, rather than going over here, it checks with the meta class first. And the meta class says, I don't have it, but do check with this guy, he's the real guy, right? So then it goes and checks it. Again, that's the implementation now, doesn't mean that's what it will be ever.
So theoretically speaking, there would be one extra step for the JVM to find these dynamically added.
It'll be the extra step for your code to go find it. It's not the JVM that's doing it, it's the implementation of the language on top of it, yes. And you're concerned about performance, I would assume, right? Yeah. Again, vtables were slow, object-oriented programming would never run, right? Yeah.
Thanks.
So, then just a couple of minutes, I'll just mention this. In terms of delegates, you can apply these concepts, and effectively, we all know that inheritance is one of the worst concepts to use in object-oriented programming. Delegation is much better than inheritance. Why? Because inheritance should be used for ease of relationship. If your intent is not a ease of relationship or a kind of relationship, but your intent is to reuse the code, a delegation model gives you a much better reusability. Well, that's all a great, nice theory, and we all agree with it. We sit back and start coding. We say, forget it, I'm using inheritance. Why? Because inheritance is easier to implement. Delegation is so hard to do. There's a term for this. It's called viscosity. Viscosity is where it's very difficult to do the right thing, and it's very easy to do the wrong thing, right? So the languages and frameworks create a lot of viscosity around us. Well, if delegation is so easy, you would much rather do that. So here's an example of how you can do that. So I'm going to use this method missing concept, and the manager is going to delegate these calls to these other objects. So basically, when you call the method, I'm going to check what you're calling, and then send the call. The manager is going to send it to a worker or an expert. So the manager itself, notice, doesn't have much methods. But the worker has the methods, expert has the methods, and the manager simply routes it. I can't go into the details over here, excuse me, but when you refactor this code is going to look something like that. Look at how trivial that is to implement now if you use metaprogramming, right? So I'm going to say manager, delegate calls to worker, expert, and something else, and you're done, right? And it's going to sit there and say, okay, call methods on me, and I'll find out who implements this method and route it, and enhances your capability and gives you reusability. This again is done fairly well. This was a concept introduced by Rails, and then eventually it's kind of trickling into Ruby, where you can have delegation models, a very powerful model to route calls. You can do that too in your own applications. So with that said, a couple of references. Probably one of the good references to go back and read is about small talk patterns and practices. Go back and look at some of the old patterns and see how we can bring them back to life. Of course, the well-known Design Patterns book by the Gang of Four, you can take a look at it. I've also got a number of these in my book on programming Groovy. You can take a look at it also if you're interested in. That's all I have.